Hello, my name is Javier, and in this short presentation I will introduce the ongoing and future works related to task 4.2 of the DaCapo project regarding the PESMEL use case. The goal of this task was to optimize the generation of warehouse layouts through artificial intelligence, just to determine the best arrangement of aisles and cranes according to technical and eco indicators. In this PESMEL use case, warehouse looked like we can see in this figure. Here we can see some layout image. For each layout image, we have supporting structures in blue, we have storage locations, which are the regions in white. We also have the aisles, which are these yellow straight lines, and also there are one or more cranes per aisle. And the goal was to get the configuration that optimized the output key indicators. In the present task, and just by implementing state-of-art conditional generative models, we could provide a smart solution that generated multiple configurations to enhance the storage capacity, the space usage, and the roles accessibility, while also minimizing the CO2 footprint, which depended on the amount of steel usage. And we were also able to assess the disassembly capacity of the warehouse. When we talk about generation of new layout images, we referred to the choice of these technical details, of this technical aspect, and at this point, for each combination of these design feature values, we could generate the associated layout image and also its associated key indicators. Then, by repeating this generation multiple times, we could generate an extensive database containing more than 7 million of layout images. The generative model implemented in this PESMEL user case was trained with this dataset composed of multiple layouts, and it was a conditional tabular adversarial network, usually known as a CTGAN, which consists of a generator and a discriminator neural networks competing against each other, with the generator being trained to create synthetic data and fool the discriminator, which at the same time is trained to distinguish between real and fake data. On the top of that, we worked with tabular data and we could fix some of the features. So with this architecture, we could produce new realistic samples that met users' criteria regarding these technical and eco indicators. So we could fix and we could generate samples with the desired space usage, rows accessibility, storage capacity, disassembly, or CO2 footprint, or the associated amount of steel usage. From the user's perspective, the user needs to provide the total space available for the design and the desired storage capacity, for example, just to obtain multiple generated layout configurations. And apart from these key specifications, other filters can be made on the designs. For example, the user can also fix the desired number of cranes, the number of aisles. He can also fix the rows accessibility or any other property.
And how can this application be used? Well, in general, the user will indicate the technical details and the key indicators to be fixed through a JSON file. And this is how this JSON file can look. Here in this example, the user is fixing the total space to 8,030 meters square, the aspect ratio to 1.2, and the storage capacity to 40,000 meters square. But in general, any of the technical details or key indicators can be specified. So these are all of them, these are all the possibilities. Here we can see also this JSON file in a formatted way, just for visualization. And once this JSON file is prepared, then the code can be run and automatically the CTGAN will generate samples just by producing values for the remaining columns, for the remaining features, not fixed. And once this is done, then several samples are generated. We can compare the values. For example, here we have two samples, this one, and these correspond to the values for all of them. And here we can see the layout image for the best one, for the sample which is closer to the value that we would like to have for all of them. Here we can see the values for the inputs and for the outputs. This is for the technical aspects and for the key indicators.
And in the upcoming months, an extended version of our available city guide will be evaluated, extending the current parameter space to increase the scalability of the tool. And in addition, a reinforcement learning framework will be developed to adapt the responses of the generative model to the user's preferences in a smart and holistic approach. We will also integrate this software on the DSS.